Hi and welcome to the Insight My Life channel. So today we're going over the SOA published exam questions, and in this particular case we're going over exam question 326. So the first thing I want you to do is take a moment, look through the problem if you haven't already, and pause the video here. And we're going to begin going over the answer right now. So the first thing I want to talk about is what is the incorrect way to do this? And it's easy to assume that this would be the correct way. And it happens often enough that I feel that we should address the incorrect way first. So it's easy to assume that since the variance of a Poisson distribution is equal to the first moment of a Poisson distribution, that we can treat the variance of the mixture the same way we would treat the expectation. So in other words, it's easy to just take the variances and weight them. But that's not actually the correct way to do this. So let's take another example then. Imagine the same type of problem, but this time with only two risk classes, a high and low risk class. So the high risk would occur 30% of the time and be uniform on 2 to 4, and the low risk would occur 70% of the time and be uniform on 1 to 3. So I'll leave calculating the variances of a uniform distribution up to you guys, but take my word for it that the variance of each of these is 1/3. So would it make sense then that since the variance of these two different distributions would be 1/3 overall? Well, no, because if you think about it, we have an additional variance that occurs in actually selecting the risk class, because the high risk occurs 30% of the time, right? And the low risk occurs 70% of the time. So that means that there's an additional variance component that's not actually being factored in when we simply weight the variances. So after we cover this problem, I invite you guys to go ahead and try and rework this same problem, but using uniform distributions like I've given below. So now let's take a look at what is the correct way to do this. So it's good that we go and think about the first principles we have here, is that the variance is equal to the second moment minus the first moment squared. So you can see that's the formula that we all know and love for variance. And so we're going to apply that to this problem. So even though you can't weight the variances and get the answer directly like that, you can still weight the moments. So remember, moments being the expected value of x, expected value of x squared, etc. So the expectations, basically. So let's go ahead and think that the first thing that we are going to do is do the expected value of x, the first moment. So we're just taking those expected Poisson variables. So remember that the Poisson variable, for that, the expected value is equal to the variance. So be careful here, because the next thing we have to find is the expected value of x squared. So what is the expected value of x squared for a Poisson distribution? Well, let's kind of think backwards about this. Since the variance is equal to the expectation for a Poisson distribution, then we can take our formula for variance and then we can change it for the Poisson distribution. So we're going to say that the expected value of x squared is equal to the variance of x plus the variance of x squared. So if that's not clear, that's because what I'm doing is I'm substituting the variance. See how I have the variance of x is equal to the expected value of x squared minus the variance of x squared. So I'm just simply substituting that expected value of x for the variance of x, because it's the same for a Poisson distribution. So now we have a formula for the expected value of x squared. So now what we're going to do is we're going to weight that. So we have the expected value of x squared, so I'm just taking 20 plus 20 squared and doing that for each and weighting it by the respective probability. And I get the expected value of x squared is 180. So now, to get to our final answer, we're going to take the expected value of x squared minus the expected value of x to the power of 2. So when we do that, we get to our final answer of 23.75. So thank you guys for watching. More videos coming soon. Don't forget to like and subscribe.